Hi viewers, today I have come with a good topic or excellent topic, that is CB configuration of transistor. CB stands for common base. Okay, so let me enter into the common base. Yeah, common base configuration of a transistor. So about the transistor only I am going to speak. So transistor can operate in three different regions or three different modes or in different configurations. One is common base, common emitter, and common collector. So now common base. In common base configuration, base is common for both input and output, right? So base is common for input and output. Hence, input is applied between the base and emitter. So that is why it is applied to the base and emitter terminals, and the corresponding output signal is taken between base and collector. So it is the input section and it is the output section. The base terminal is grounded, so always it is grounded. Current gain or amplification factor, the ratio of output current to input current is called current gain. Okay friends, the ratio of output current to input current is called it's called current gain or amplification factor. Here output means it is a input and it is output. Input current is IE, output current is IC. So IC by IE. So if you write like this, it is for DC only we write. For AC we have to write like this: change in IC by change in IE. DC means direct current, for AC means alternating current. So this is at constant VCB. When VCB means output voltage is constant, VCB, this is output voltage. And here one thing you must keep in mind: how can we know the emitter, base, and collector? So on the emitter only you may find the arrow mark. So on which line the arrow mark is set, that is called emitter, and the one is collector. And next we know the base is always like this only, always base is middle of this one. Next, input parameters. See here, input parameters means input components. Input component is VEB and IE, VEB and IE. Output parameters are IC and VCB, IC and VCB. Input characteristics. So here our aim is to explain the input and output characteristics only in this topic. The variation of input current with input voltage VEB at constant output voltage VCB is known as input characteristics. See, input characteristics means output VCB we have to keep constant. VCB is constant. And what we have to do? We have to change variation of input current. Input current is IE and input voltage is VEB. So when we change VEB versus IEB, so different values of VEB, different values of IB we have to calculate, but at constant VCB. So this is called input characteristics. Variation means change in changing VEB, change in IE we get. So at what? At constant of VCB. VCB is output voltage. First, keep VCB constant and vary VEB values and record IE values at each input voltage VEB. See here the diagram, in the diagram also given, so let me explain later. That is okay. Repeat the same process at a different output voltage values. Now plot the graph between IE and VEB parameter. Okay. First what we have to do, we have to change VEB, okay, and note down IE values, okay. At a different VEB, note down the different IE values. But what we have to do, we have to keep output VCB constant. Output voltage is constant, okay. At constant means suppose output voltage is 1 volt. At 1 volt different VEB and different IE we have to calculate. Next, change the output voltage VCB, change it as 2 volts. Okay, and now again VEB and IE values record now at this values like this, at a different VCB, different VCB, note down that VEB and IE values and draw the graph. So if you draw the graph, we can get graph like this. So at a VCB, the graph is like this. At a VCB 1 volts, at a VCB, see here VCB value is increased, then we got this line, and VCB value again increased, we got this, we got the first line. Okay, so like this. Figure shows the input characteristics curve in CB configuration. So it is a CB configuration input characteristics. The characteristics curve shows that at constant output voltage VCB, at constant output voltage VCB, output voltage is constant VCB, the emitter current does not increase initially with EEB. So VEB you are changing, but initially IB cannot change, that is there, till it reaches a value, till it reaches a particular voltage, that is called cut-in or offset voltage. Okay, in figure, it is shown in figure. See, latter increase with emitter base voltage. Okay, so later what happens when we increase VEB, IB also increases, so that is shown like this. Okay, but up to certain voltage, IB cannot change, it is shows 0 values only. After reaching a particular value, that is called cut-in or offset voltage only, then only current starts. Okay, the curves are similar to diode characteristics. So in the diode also we can get the same line like this. Like this also we get in diode. The collector to base voltage has little effect on input current IE, right? So on input current IE, collector what current? Input current is input current is IE. So little effect there. Which one? Collector. So that is why, because of this only, current is what is happening, it is increasing at the beginning only. From the slope of the curve it is clear, from the slope of the curve it is clear that input resistance is low. As output voltage is increased, the curve becomes more steep, means more sharp. Here see, as a VCB is increasing, so at lower VCE, so we got the current here, and VCB is increased, so see current increasing before only, it started before only. Again if you increase the voltage, again current starts previous only, and it reaches maximum value. Okay, next, output characteristics. The variation of output current IC with the output voltage VCB at constant input current IE is known as output characteristics. In input characteristics, what we observed, changing VEB, calculating IE, but we kept VCB constant. But in output it is in input characteristics. In output characteristics, see, changing VCB, we have to note down the IC, but which thing we have to keep constant? Current, input current we have to keep. In output characteristics, input current we have to keep at constant, but in input characteristics, output voltage we have to keep constant. Okay, so that is a difference. Okay, figure shows output characteristics in CB configuration. The output characteristics indicates 3 regions. So what are those 3 regions? One is saturation region, active region, and cutoff region. So what are the saturation region, active region, cutoff region? Let me explain one by one. In active region, the collector base junction, only output section we have to see. Collector base junction is reverse biased, and emitter base junction is forward biased. So suppose the transistor has to work in active region, then input section must be in forward bias, output section must be in reverse bias. In this region, IC remains constant for IE even when VCB is changed, right? Even if we change the VCB, IC is constant for IE. When value of VCB attain a threshold or maximum value, increase IC increases very rapidly due to the avalanche effect shown by dotted line. Okay, so when VCB reaches a particular value, so that is called threshold or maximum value, what happens, it increases very rapidly, fastly, and due to avalanche effect. Already avalanche effect is explained in the diode avalanche effect, and that is shown in dotted line. See, dotted line, these are the dotted lines. As a input current, we kept constant, first is 0, and we may get this one, and again if we increase, so increase in values we got, again if we increase value, and here but we got here extra terms, extra current we got, saturation current. In saturation region, see, in saturation region both junctions are forward biased. There is a small current IC even in the absence of VCB. When VCB is 0, even though there is a small amount of current. Okay, in saturation region means both junction, input section and output section must be forward biased. Both sections, input and output section, must be forward biased. Then only that works in saturation region. In cutoff region, see, in cutoff region both the junction means input section and output section must be reverse biased. Then only it works in cutoff region. One is forward and other one is reverse, that is active region. Both are reverse, that is cutoff. Both are forward, that is saturation. In cutoff region, junctions are reverse biased. A small IC flows in this region even IE is 0. Even IE is 0, there is a current, see. So this is known as leakage current, ICO. It is called leakage current. And here applications also we have, those applications, see here. Common base configuration circuit is mainly used in single stage amplifier, and in radio frequency amplifier also we use. Okay friends, so these are the application. Thank you.